Hello, this is Mr. Cox with another video, Supercharged Science. This one is about the Earth, Moon, and Sun system. Now, there's a lot of different areas you could go. You could talk about gravity, you could talk about a whole lot of things. I want to talk mostly about how they move together and about the light coming from the sun. The moon's albedo, that is, the amount of light shining off of it, is reflected from the sun. It's not really putting off its own light. There is something that happens when it's a full moon sometimes called earth shine. I'm turning the base of it so you can see as it goes around there right now. So I want you to kind of see the earth and the moon. The whole thing is actually the earth and the moon are going around the sun like this. Back it up a little bit. What earthshine is, it's the light coming from the earth reflecting on the moon, and you can see when the moon is new. I said full. When the moon is new, meaning it should be completely dark, or it's mostly dark and there's just a little sliver of a crescent, and you can still see the dark part of it lit up a little bit. That's called earthshine. It's the light shining back from the earth, reflected from the sun. Of course, the earth, because of all of our people here, is putting out a little tad bit of light as well. So, but most of it's coming from the albedo of the earth. It's the amount of light shining off of it from the sun. Will kind of light the moon up just a little bit. But the side of the moon that's facing the sun is going to have the most light coming from it. So as the earth and the moon moves around the sun, notice that the earth is moving around the sun, the moon is moving around the earth as well. I'm shifting it up this way a little bit. When the sun faces you there, it may get bright for a minute. I'll speed it up so you don't get the light in your eyes very long. Now, notice, and I'm going to turn this back here. This causes the phases of the moon, as the moon is going around the earth, and the amount of light coming from how much of the earth's surface, how much of the moon's surface is being illuminated directly by the sun, and how much of it is not, gives you the different phases of the moon. From just a geographical positioning of it and the way you look at it, here you can see there's different parts of the earth that are being covered by the moon and being blotted out. So when you get a lunar eclipse, this is when the portion of the earth that you're on, you can see the dark shadow there, is made completely dark. That's a total eclipse because the moon is covering the disk of the sun in the sky. Now, this is kind of an interesting thing, but the moon's and the sun's size and the earth's size and all their distance to each other are just, like I talked about the Goldilocks zone before about life, these are just in the Goldilocks zone for really being able to have a solar eclipse. And there's a lot of things that we would not have learned about the light coming from the sun through something called spectral analysis, where you take a pyramid or you take a diffraction gradient and you break down the light coming from the sun. We wouldn't know a lot about that, to see what elements it's made out of, etc., if we had not been in a system where the size of the moon, the distance from the sun, and the distance of the earth was just right, so there could be something called a total eclipse. But something else I want you to think about, I don't want to spend a lot of time here on flat earth versus spherical earth. People get really mad about that, but this is something that even the ancient Greeks, the ancient Romans, and the ancient Egyptians knew about and realized that the planets, including the earth, are spherical, and the moon and the sun are spherical. You can easily see when the phases of the moon occur, there's a curvature there. It doesn't get all light once and all dark all at once. like it would if it was a flat moon. And when there's a solar eclipse, you can actually see Earth's shadow crossing the moon, and you can see it's curved. And not only are we talking about it being curved, but we know the moon is not just a flat surface, but it's not a disk, but it's actually a sphere, because you can see the curvature of it. And you can see that there's parts of it that are illuminated or lit up and parts that are not, and the shadow moves across it. Same thing with the Earth. Now, it's easy to see from the International Space System, for space shuttles that we used to fly up there, from all of our space missions, that you can see the sun rise and set. You can see the curvature of the Earth. You can see the sunset go in a curvature pattern. If the Earth were flat, even if it was a flat disk, if the sun was going around us, then you had to account for where all the planets were going as well, why they weren't going around the sun, and how they were not running into each other. But you would also notice that when morning came, it would be like a split second, and it would be just like somebody flipped the light on. The whole Earth, clear across it, would be completely bright, and when the sun went down, it'd be like somebody flipped the light off. Boom, it would be completely dark. There would be no dusk, no dawn. But we see the sun's shadow, the sun's light go across the Earth as it moves around. And so part of the Earth is dark, part of it's light, and there's time zones. All this occurs because of the curvature of the Earth. There's a lot of things we could do with this, but let's wrap it up in that one. Notice I'm speeding the Earth and the Moon system way up. The Earth is on average 93 million miles from the Sun. In North America, of course, and notice that the system is tilted on when North America, the Northern Hemisphere even, is in our summer season. We're actually a little farther away from the sun than we are in our winter. And when we tilt back where it's warm, we're actually a little farther away. So you would think it would be warmer when we're closer and colder when we're farther away, but that's not the thing. It's just a million miles difference. About goes from approximately from 92 to 94 million. That's not exact, but approximately averaging out 93 million miles. But the tilt of the Earth is what causes the season. Of course, in the southern hemisphere, in the part of it that they're having winter, where we're having summer, and summer when we're having winter, they're just the opposite. They are closer in the summer and farther in the winter because of the tilt. The Earth and Moon gravitational pull are very important for all of our seasons, for the tides. Those are caused mainly by the moon. All of our life systems are based on those tides. Without this relationship with the moon, life wouldn't exist here. There's just some people here lately coming up with the idea that maybe the moon is just a hollow base for ancient aliens and things like that. Well, I'm sorry to tell you, but if that was the case, the moon wouldn't have the gravity that it has. Number one, we can measure the gravity relative to the size. And also, if it had just been an alien base brought here, we wouldn't have had the gravitational pull, enough of a gravitational pull for the tides, and we wouldn't have had any life until those tides began. Those tides, all the ocean life, are based on those, and then all the other life systems, the birds and everything based on that, are based on those tides. So it's a very intricate system that's interlocked. You know, I'm not saying there couldn't, who knows, there might be caverns or something underground on the moon that we haven't found, or something like that, but I don't think the science is there at all for it being just a hollow spherical metal alien base or something like that. So you'll see a lot of different ideas come out of that. And some of the people that say that are people that I respect about some of the other things that they say when they're talking about real science and real history and real things, but that's weird, and I have issues with that. So that's it for all I want to talk about was the Earth-Moon system for today. I'm going to turn it off without flipping the lights on and make it really bright. I'll see you in another video.